Hey everybody, it's Christmas Day 2016. It's actually the evening now. My wife actually headed out the door with the kids and has gone to visit some relatives, and she'll be back in a couple hours. And in the meantime, my job is going to be to try and fix a microwave. No, not this microwave. This microwave is the one that failed, which is because it caused me to work on another microwave. I can't fix this microwave because I actually already know exactly what this one needs, and although I could get the part, I think my wife would rather I didn't fix it. Now, I ended up getting a little microwave for free recently that was in very good condition, and my wife wanted me to put that microwave up on the shelf where this microwave has been located before the holidays. And I said, I really hate the idea of swapping this microwave out. Why? Well, because this microwave has been so good to us. This microwave, she's actually had this microwave longer than she's had me. That's how long this microwave's been around. And this microwave has never, ever needed to have me work on it. It's always worked. It's always been there for us. It's a sharp carousel microwave. It's a very simple design. There's no clock on this thing. It's not digital. It's got a electromechanical clock mechanism that when it winds down, gives you a little ding to tell you that the food's done. It's got two settings, cook, defrost. This used to be white, but it's actually yellowed from age. Got a door open button, start button, carousel. This microwave has just been fantastic for us. This microwave was made in, this is a model year 1985. This is a model R5565. I actually used to service microwaves at my repair shop back in the day. That was back when people actually brought things in and had them repaired. And one of the services I performed was microwave repair. Believe it or not, microwaves were still costly enough to buy that it actually made sense to have them serviced and repaired if it wasn't a catastrophic event. And I'm going to work in a little bit of the technology of the microwave as far as the nomenclature goes. I'm not going to get into the too detailed because I'm not an engineer and I'm not a scientist. This is just from a technician's standpoint. I'll let you know what I know about them, and we'll go from there. But we'll start by saying why I'm not fixing this one. Well, I'm not fixing this one because, again, she doesn't want me to fix it. And B, because what this needs a part called a waveguide cover up underneath here. And the waveguide cover on this one burned. And it stinks. When I open that up, it stinks to high heaven now. So that little charred black area right there is a thin cover that covers the outlet of the waveguide. And I think it's made out of a mica material. And what can happen on those is grease can splatter up onto there. And this catastrophic event occurred during a major bacon cooking episode. And it started a little fire and started to burn through. And then it can just continue to burn and make a really horrible noise while it's doing it. And make some really acrid smoke. Now, if you can get a waveguide cover that actually fits that, it's the same size as that waveguide cover. You can actually remove that waveguide cover, clean that whole area really well, install a new waveguide, and Bob's your uncle. The problem is, I don't even know if you can still get waveguide covers. Back in the day when I was doing service, we actually had catalogs from companies that sold microwave oven parts. And you would just turn to the page, and there'd be a section and say sharp waveguide covers, and you'd look at the pictures, figure out which one fits there. You buy the thing for like $3 or $4 and clean it up, and you were off to the races. This microwave had actually started to slow down, though. It was taking longer and longer to cook, which is an indication that the Magnetron, which is what generates the microwave energy in the microwave, is on its way out. But it's actually been on its way out for a long time. It's kind of like, a guy who's 60 years old lost his step a little bit over a guy who's 40 years old, but that doesn't necessarily mean that he doesn't still have a long way to go before he's done. Hopefully like myself. So the funny story about this, what I think is a funny story, is how I was saying that, geez, this microwave, I hate to I hate to put that new microwave up in the place of this old one, honey, because this old one's been bulletproof. It's been so good to us all this time. I don't even like talking about it. So what happened? 2 days after we had that conversation, the catastrophic event occurred. And I actually was teasing my wife. I told her, I said, you hurt the microwave's feelings, basically. This thing committed Harry Carey. It did itself in. So the whole thing is highly suspicious to me, the timing. So what ends up happening? Take this microwave out, not going to bother with it. We put the new microwave, or the new one to us, that was clean as a whistle, up there. Everything's hunky-dory until we go to heat up leftovers from Christmas Eve last night. And the dinner plate won't fit in the microwave. We have large dinner plates because we like to eat. But we have, seriously, we have these large dinner plates. They wouldn't fit in that other microwave oven. So now what are we going to do? So she doesn't want this one fixed. The new one's too small. And then I remembered we've got another one that had been almost brand new when it failed at my in-laws' house. And they immediately just bought a replacement microwave and said, well, rather than throw it out, I said, you know what? I said, I'm going to hold on to that microwave. When I get a chance, I'll take a look at it, because maybe it's something really simple. And I don't want to throw it out because it's so new. So, fast forward to today, I've had that thing sitting for several months. I never got around to looking at it. Tonight's the night. We're going to look at it. So this is the box the new one came in from my in-laws. So it's a Proctor Silex, which is kind of funny because I bet you Proctor Silex, the original Proctor Silex company, I don't even know if they're still around, and if they are still around, I bet you they had absolutely nothing to do with making this microwave oven other than licensing their name to be stuck on it. But anyways, I might be wrong. Who knows? I bet you they paid all of 50 or 60 bucks tops for this, maybe even as little as 35 or 40 bucks for this thing. Probably at Walmart or Home Depot or one of them places. But I took the new microwave, set it up for them, made sure it worked. And then I stuffed the old microwave right in this box and carried it on out. And what was in here, what's in here now is the old microwave. It's a 0.7 cubic foot countertop microwave, a model OGT 6701 by Oster. They even had the owner's manual still. Not that you need much of an owner's manual for these things. And even if you do need an owner's manual, you can get almost every one of them online now. How do I know that? Because we had trouble working in the microwave that's up there right now. It had some fancy schmancy defrost features. You could defrost by weight and stuff like that, which we don't go in for. We couldn't figure out why the thing wouldn't let us enter in a time for defrost, and it's because we were in the by weight mode and it was looking for ounces and it didn't like what we were trying to put in for ounces. But I digress. A little dusty from sitting down here in the basement. Uh-oh. Well, I'm sure that doesn't belong to this. You know, as microwave ovens go, this actually isn't a bad looking little oven. Hey baby, come around here often? So back in the day when somebody would come in with a microwave for repair, of course we'd fill out the slip, get all their information, contact info and everything like that. And the first thing we ask them is, well, what are the symptoms? Well, with microwave ovens, there's not a lot of symptoms you tend to get. And this is probably the most common symptom we would run into. DOA, dead. DEAD is typically what we would write right on the slip. You'll notice I plug it in, 0 clock. The digital display has not lit at all. Now on some models, you might not get a display until you actually started pressing some of the buttons to key in like the time of day clock. Or on some you'll get just 2 dots until you do that. But this is dead, dead, dead. There's absolutely, for all intents purposes, there appears to be no power getting to the PC board up front here that basically runs the whole show. So, oh, by the way, the second most common complaint is no heat, not cooking. The thing would turn on, run, countdown timer, everything would work, but you take your food out and it would be stone cold. So in this case here, we've got the DOA. So at this point in the video, I'm going to give the old disclaimer and let you guys know that I absolutely do not advocate taking apart or removing the cover on any electrical appliance. unless you have a clear and concise understanding of the dangers involved. So, you've been warned. This is just for entertainment purposes only. I'm not trying to show you how to fix this thing. Don't even try and, don't even try and think that. Pardon me, there's a lull in the action here as I go in search of my security torque sets because, dum dum dum, bit of dirty pool this manufacturer pulled over here. Speaking of trying to keep you out of here, crying out loud, is that really necessary? Security torques? Come on. Now, I remember the last time I needed to use my security torques bit set. I couldn't find it. And I ended up going and buying the one size that I thought I needed, which was a T10. I never did find that other set, and haven't gotten around to replacing it. And I really need to get that set. But, a lesser man might be daunted by this and give up. But not moi. Not moi. Now the screws on the side here, of course, regular old Phillips head. They came to their senses when they put these in. Guess they couldn't find any black ones. Now, I gotta show you this because I just think it's a hoot. 2 screws on this side, only 1 screw on this side. What the hell's the point of that? So there's a metal like tongue down here on the cover that actually catches this front lip right here. So you got to kind of raise the cover, tilt the cover back and pull back, and it'll disengage from that. Now I've got the microwave unplugged, which is, well, that should be common sense to have the microwave unplugged. However, there's still a potential danger of electric shock even though the microwave is unplugged, and that is because of the capacitor down here could invariably have stored a charge. Now, this microwave has been unplugged and unused for so long that any residual charge is probably all but completely gone. Also, there should be an internal bleeder resistor that should bleed that off. However, that being said, who knows what kind of weird thing might align in the cosmos to cause a situation where, for whatever reason, that thing is charged. So, always, how's that saying? Hope for the best, plan for the worst. So, anyways, my whole point is I'm not going to be sticking my fingers in there touching anything even though it's unplugged, just in case. But I'm going to give you a quick little rundown of the anatomy of the beast. And I'll start with this top section here, and then I'll move the camera down. That way I don't have to have a faraway view and all this other stuff. That's an over explanation. All right, we'll cut this out, edit this out. All right, so anyways, we're going to talk about what's in this thing. Okay, this is the heart of the microwave right here. This device right here is called a Magnetron. I've never, ever, ever seen this brand of Magnetron before. Of course, it's been quite a few years since I opened one of these puppies up. This is a Galanz, G-A-L-A-N-Z Magnetron. I have serious doubts that that is not an Asian-made Magnetron, even though it has a name that sounds kind of European. Galanz. Okay, Magnetron. This Magnetron is mounted horizontally. In other words, the top of the Magnetron is actually facing that way, so that it's basically got almost no waveguide on this thing, which is not how you typically see them. They probably did this because it's such a small microwave, only 0.7 cubic feet, which, by the way, I don't think my dinner plate's going to fit in there either, but I promised the wife I'd check this thing out, so I'm checking it out, all right? Yeah, don't give me any slack. All right. But that's probably to keep this very low profile, and because it's such a small cavity, they were able to mount this thing horizontal and keep it very small. Typically, I would see these mounted vertically, facing up, and they would shoot the Magnetron. The Magnetron would shoot the microwaves into a metal box, an elongated metal box that went over to the top of the cavity, called a waveguide. Okay. But they didn't do that here. So what we got is we got the magnetron. The magnetron generates microwaves when high voltage AC is applied to it. Oh, I'm sorry, AC, DC? DC, I think. Yeah, DC is applied to it. So what you got is you got right here, this is where your high voltage connection is. That's why you have this insulator, which just looks like cheesy plastic, quite frankly. But in the old days, this was actually mica on a lot of these, or not mica, but ceramic. All right. Over here, we have the cooling fan. The cooling fan is situated right here, and basically it blows air through the fins on the magnetron and cools it. So there you can see the cooling fins on the side of the magnetron. This is just a light socket for the light bulb that lights the cavity when you open the door. This right here is a thermal cutout or thermal couple. This is screwed to the cavity. If fire breaks out in the waveguide area here and this gets hot enough, it will open and it will stop the current flow and basically shut down the whole show. There's a second one of these devices screwed right to the side of the magnetron. If the magnetron shorts out or for whatever reason gets too hot, that will open up and also shut it down. This is interesting over here. This is a power input board. So on most of the microwaves that I've serviced over the years, this board didn't exist. This has got a RF choke on it. It's got what looks like these blue devices most likely are metal oxide varistors, probably for surge protection, or they could be capacitors. But they're probably either for line noise or transients, not sure. And the all-important ceramic line fuse. This line fuse right here, the AC comes in and goes through this fuse before it goes anywhere else. So this fuse is most likely blown, which would be why it's dead. The question is, why did it blow? I'll get to reasons for it to blow in a moment. Let me finish the anatomy lesson. High voltage transformer. This transformer has only one job. It produces the high voltage to run the magnetron. It's part of the high voltage circuit. The high voltage circuit is basically the magnetron, the transformer, this large capacitor over here, okay, and then more than likely in this white plastic pouch right here is the rectifier. So we've got a diode, capacitor, transformer, and magnetron. That's the whole circuit for cooking. That's what makes the microwaves. You could take all these components out, lay them out on the bench, apply 120 volts AC to the primary of this transformer, and this puppy's going to fire up and start making microwaves. And that's very ill-advised because you're going to cook yourself. Bad things can happen. Don't do it. Ever. So you probably think, oh, so Steve, what's left? If that's the whole show right there, what do we got left? Well, you get a PC board right up in the front here with what looks to be a microprocessor. Yeah, we got a microprocessor. I can see the crystal there, which is the clock. And this microprocessor is basically going to run the whole show. It's going to give you a time of day digital clock, but it's also going to handle all the other functions. We've got some PC board mounted relays right here. Okay. You got a little daughter board mounted vertically. That's kind of a shady design. And then you've got the soft touch button membrane on the front there. Comes through this ribbon cable to the board. And then, I don't know how well you can see it, but right behind here, this device right here is a micro switch, and there are often more than one. And what the micro switches do is the micro switches have a couple different jobs. The micro switches are responsible for turning the light on when the door is open. The micro switches are also responsible, and the most important job they have is the micro switches are responsible for not allowing the microwave to be started with the door open. So what you got these spring-loaded plastic hooks right here, okay? And when I close the door, okay, they snap up into place, and now I can't pull that door open. unless I really, force it and break it. You have to push this button here to disengage these and allow this to open. Well, when these close, another thing that they do is they basically trigger one or both of those micro switches. And there's actually a way that they interact, the switches interact. On some of the older microwaves, you'd have several of those switches. And sometimes you could have a situation where something would be out of adjustment and one switch was opening or closing when it wasn't supposed to and could actually cause a short. So what you would get is you'd get a symptom the microwave was dead. You'd replace the fuse, and every time the person would close the door, it would blow the fuse. Or every time they went to open it, would blow the fuse, or something crazy like that. That was pretty rare, and by the looks of this design, I'd say that they probably don't have that problem, that couldn't be the potential problem on this thing. And again, the whole purpose is to make sure that you can't run this microwave with this door open, because if you do, microwave energy is going to come out and it's going to cook your face as you're watching your popcorn pop, okay? Not good. So let's first verify that the fuse is blown. So, of course, what I'm going to do is I reach for my oldest digital multimeter, the one that's so old it doesn't even have an audible continuity check. And I'm going to go right in here and I'm going to put the leads right across the fuse. And I see OL, which means out of limit. And what I would rather have seen is this, which is 0.5 ohms, which is really just the resistance of these crappy meter leads coupled with the resistance of the bad connection that are probably... Oh, look at that, it's getting better. So the fuse, she is cooked. So there's my fuse, but I don't have my reading glasses, and I don't know how I'm ever going to figure out exactly what the ampere... Oh. It's 15 amps. I'm Batman. All right, so 15. Now, obviously, there are all different types of fuses, and there are, different sizes and types and amperages and everything, and we actually have various nomenclature over the years that have been used to describe sizes of fuses. For instance, this is a AGC. So you've got, AGC, BAB, BA-BI, BI Bicky by Bo, QA Quake, and so on. But what we need, I believe this is, as I recall, an F-type fuse. F as in your, well, never mind, I don't know why they call them that. Well, while we're on the subject of fuses, I also want to point out, you may notice that this fuse is white, and you can't see the filament, or the little tiny part inside the fuse there. So when this fuse blows, you have absolutely no way, by visually looking at it, that it's blown. Whereas on these glass fuses like that, you can see that little filament, that tiny wire that's inside there. And you can either see that there's a gap in the wire where it melted open, or sometimes if it blows violently enough, you'll get a black spot in there. Matter of fact, I've seen fuses of this type blow so violently in power surges that the little filament becomes vaporized metal, and at high velocity strikes the glass and causes this really neat coating on the glass. But I digress. Point is, if your application calls for a ceramic type fuse, you're supposed to use a ceramic type fuse. We even actually called these microwave fuses back when I was doing service, because the only thing that we would tend to see these in were microwaves back in the day. Whoa! Look what I found. Proof that I wasn't always this disorganized. This actually, I used to have this in my repair shop, and this is how I organized my fuses, and it basically pointed out to me that I think I already said something wrong. GMA type fuse, I believe, is what we call those little ones. There's, yeah, here we go. So that's a 1/2 amp GMA. That's a real small sucker there. But anyways, the problem is, see, these are all regular glass fuses, AGC, and then over here I had the draws that were labeled ceramic AGC. So these are going to be the microwave fuses. 12s, 10 amps, 12 amps, 15s, and even 20s. But they're all AGC size, the bigger fuses. So I can't help but wonder whether or not I originally had these two draws in here, and if they had the AGC
the GMA ceramic fuses. I think actually most of the microwaves I worked on back in the day did not use that size fuse. A fuse! A fuse! My kingdom for a fuse! I can't find a fuse. But this is the largest fuse I have in this size. This is a 3 amp. And there's no way I can use this fuse to run this microwave. However, I can use this fuse to continue troubleshooting this microwave. Because 3 amps will be more than sufficient, or should be more than sufficient, to run the front end, so to speak, of this beast. The digital electronics on the PC board, the microcontroller, even the light. So I should be able to actually run this. And what this is going to do is, in any troubleshooting situation, you kind of want to use a divide and conquer mentality. You got to pick a point where you're going to, dive in and then see what direction it takes you. And this is probably true in many things in life. But a great place to divide and conquer in the troubleshooting of such a simple appliance as a microwave would be isolating the high voltage, high power circuit, which again only consists of the diode, capacitor, transformer, magnetron, and isolating that from the rest of the stuff. So what I'm actually going to do is I'm going to take off one of the 2 wires that actually goes to the primary winding of the high voltage transformer. Okay, pliers. Sliding the plastic boot back on. Okay. Alright, so by taking off one of the 2 leads to the primary winding of the transformer, I'm basically isolating that whole high power circuit from the rest of the microwave. So, if I plug in the microwave and it immediately blows the fuse, that will tell me that more than likely my fault lies somewhere in that so-called front end of that circuit, which is highly unlikely but possible. And I might even look at door interlock switches as a probable cause, or more catastrophically, a short circuit in the power supply that actually runs the microprocessor and all the electronics, which if that ends up being the case, it's pretty much game over. Another possibility is if there is any kind of a surge protection device, if this was hit by a power surge and there is a metal oxide varistor somewhere on one of these PC boards that was supposed to absorb the energy of the surge, and in doing so give up its life to sacrifice and save whatever else. If that device exists in here and has taken the brunt of the power surge, which we don't even know if it was a power surge that killed this thing, well, then that could be the culprit too. But enough talk. Let's plug this pig in. That beep, ladies and gentlemen, signifies to me that I am going to see a digital display that's lit. Voila. Alright, so there's my time of day clock. I believe I just set it to 1:23 for all intents and purposes, just out of curiosity. Now, I'm going to open the door. Ah, my switches are working. How do I know that? Well, at least I know one of them's working because my light came on. When I first closed that door, just for a second, the fan actually ran. There's a perfect example of that whole weird way that those interlock switches work. They're double throw switches, and oftentimes, so as one contact's breaking, the other one's making. But there's a brief moment there where it's kind of in between those 2 states, and for that fraction of a second, it energizes the fan because of the way the thing's wired. And that's all the more reason why if you have one of those switches get a little squirrely on you, it can actually cause it to blow a fuse. Now, for those of you who have no reason to believe me, because I just appear to be a shady character in general, allow me to see what I'm doing there. As I release this, you can actually hear the clicking. So when I push this in a little bit, the light comes on. And then when I push this door closed, see the fan? Move just a little bit, and I can actually just move this. Well, enough of that. So what does this tell me? Well, it tells me a lot, actually. It tells me that more than likely there's absolutely nothing wrong with this entire PC board up in the front here, that the microprocessor is running. It's already changing time. It's now 1:25, so I've been rambling on for a couple of minutes. Blah, blah, blah. Things are looking good in the front end, which means either one or two things has occurred here. We've either got some sort of a failure in the high voltage circuit. The Magnetron transformers almost never short. Okay, so let me say that from the outset. And if they open, they're not going to blow a fuse. So Magnetron, capacitor, diode, or maybe while the microwave was running and somebody was cooking something, there was a transient voltage event of some type coming in through the line, and the voltage went a little high, and that caused the current to shoot up, and the fuse popped and basically protected everything. Because sometimes you just get one of those fuses pops, you put a new fuse in, and everything's good to go. Now, if the fuse keeps popping, well, then obviously, if it blows immediately, you know you get a dead short. If it, we have to test run. Back in the day, we would test run these things several times before sending it back out, because you don't want the customer to get all the way home, pop their popcorn once or twice, and then have it blow the fuse again, which would indicate you had some kind of an intermittent short, which intermittents are always the hardest to diagnose, because they're kind of a now you see them, now you don't type of thing. All right, so now let's see if my little, 3 or 4 amp fuse, let's see if it's got enough amperage to run that fan and the light. Because basically the only additional amperage draw we're going to see when I energize this is, well, to get extra technical, the voltage involved in closing the coils on the relays that are mounted on the PC board, the fan, and the light. We already know it can handle the light, so we're just going to add that little bit of extra current there, and the 4 amps should do it, should be able to take it. So cook, 2 minutes, start. All right, all that clanking is just my carousel fell out of position here when I had it up on its side before. All right, let's try that again. Not that it matters. Cook. Come on. Oh, it was still set. Okay, all right. Pas de moi.